Welcome to the first video in the series of videos on current electricity. In this video we intend to get an overview of current electricity, and we may not get into too much of details and definition, but the idea is to get a feel and perception of what is happening behind each of the parts. So here is a circuit. So you have a battery and it is connected to a bulb and a resistor. Now let's look at each of this independently. So first let's look at these wires, and these wires are called the conductors. Now the key thing about a conductor is that the conductor has free electrons in the valence shell, right? In the valence shell. For example, copper, and it has copper has a valency of +1. It's always ready to the one electron in the outermost orbit is kind of switching homes every time. All you need to do is to expose it to electric field or kind of heat the conductor, and these electrons are going to keep moving around. So in fact everything is a conductor. I mean, even the so-called resistor or even this bulb is also, the filament in the bulb is also conducting, is also a conductor, but there are varying levels of conduction. So these are not as good as a conductor as these copper wires, right? So in these filament and in these resistors, what's happening is you have a good way to look at this is you have these electrons, and as these electrons are moving, they collide with the atoms around, right? And this is just an imaginative visual representation of what could be happening. And as is due to these collisions, what happens is these kind of, depending upon the type of material, this material can emit heat or light, right? Now these resistors are kind of material which offers heat, which is energy is consumed due to the collision in the form of heat, and here in this bulb is both heat and light, and this is happening due to the motion of electrons and its collision with the atoms and so forth. Now what makes these electrons move is the electric field, and that's where the battery comes in. So in a battery, due to chemical reaction inside the battery, one end has a deficiency of electrons. That's what you represent by plus, and the other side has got excess of electron, and this is facilitated by the chemical reaction which is happening inside the battery. So once the wire is connected, then wire being a good conductor, all the electric field gets established over this whole circuit, and usually this electric field is established at the speed of light. So we say that the electric field established when you connect, and this electric field is responsible. This electric field is very similar to, you take a positive charge and we say that there's an electric field, and this electric field is exactly the same electric field. And once all the electrons in the path of that electric field is going to get attracted towards or in the opposite direction of electric field, that means that all these electrons in this are going to move in the opposite direction of the electric field. So this is the motion of electron, right? This is the direction of motion of electron. So the electrons are moving from the negative end to the positive end of the battery. and the electric field is in the opposite direction, and that's the cause for the motion of these electrons. And it's important to understand that all the electrons are moving at the same time. That means that this electron here is moving and drifting, we say it's drifting, and this electron here is also drifting. So these electrons is drifting here. So all these electrons are kind of drifting in, oh sorry, the direction is in the opposite, sorry. So all these electrons are moving in unison. So that's the reason for the establishing of current. We say that usually the current, due to historical reasons, we say is in the direction of electric field, or opposing the direction of the flow of electrons, right? So we say that this is the direction of the current, or current direction, right? Okay, now what happens inside a battery is for every charge that comes out of the battery has certain energy level, and this energy level is represented by this 9 volts. And as 1 coulomb of charge, or that's a unit of charge, let's say 1 unit of charge has 9 joules of energy. That's what 9 volts means. So as this unit of charge is produced by the battery, and as it moves across the battery, these unit of charge as it moves across this battery, what happens is it gets a gain of 9 joules. So all these electrons, they gain certain amount of energy, which is, let's say, 9 units of energy. So we won't get into details of that. And as it goes through the resistance, it loses some energy. We say that it loses, let's say, 4.5 joules, that 1 coulomb of charge. And over here also it loses 4.5 joules, let's say, for example. So the net loss, which is 4.5 plus 4.5, adds up to the net gain of energy produced by the battery. So this is a good way of looking at what is happening in a circuit. On the right, you see is a symbolic representation of that circuit. So this is your R, this is your bulb, and this is your battery. So for ease of drawing, we use symbolic representation. So I hope you enjoyed this big picture. If some things may have been abstract, don't worry about it. We will look into the details of each of what we have talked about in the subsequent videos. So see you then. Bye.